Hello, I'm John Furrier, host of theCUBE here at our New York Stock Exchange CUBE studios. Of course, we got the CUBE studios in Palo Alto connecting Silicon Valley and Wall Street, of course, part of the NYSE Wired program and community, an open network of experts and leaders making things happen. This is our kicking off our AI Factory series, the future of the data center. As generative AI and AI native applications hit the scene, the infrastructure that provides them is the large scale systems or AI factories that are producing the outcome and the value. So as all those benefits will be realized and captured, the creation is really what's happening at the chip level. And again, these large scale supercomputers, we are living in a supercomputing era. And we got a great guest here, Vladimir Stojanovic, who's the CTO and co-founder of Ayar Labs, about to accelerate into mass production of their optical device switch. Is it a switch? It's not a switch, it's a connector. It's co-packaged optics.
It's a fabric.
It's a switch. Yes, it's software, hardware. Vladimir, thank you so much for coming on. So let's get into it. You guys have, I won't say been in stealth. You've been building intellectual property and product in really one of the hottest areas right now. Explain what you guys do. Just set the table. I know you're ramping up with TSMC and just getting ready to hit the market big. What's it all about?
Yeah, Ayar Labs is all about data movement and accelerating that data movement for AI infrastructure. We do so by building a product that is called Optical I/O. This is a product that is co-packaged with AI accelerators, with switches, with extended memory modules to allow you to have super low latency, extra high bandwidth, and really good energy efficiency in these AI fabrics. It essentially allows us to stitch together a collection of thousands of GPUs working together as one on and crunching through these big AI problems.
So you support the supercomputing era, right?
I would say it's a worldwide supercomputing, because this is no longer some supercomputer in a government lab.
Yeah.
It's really world accessible supercomputing.
We really love this series because AI Factory is a nice marketing term that Jensen Huang put out there a couple of years ago as a conference, as a GTC conference, but it really abstracts away all the work being done under the covers, under the hood, because the outcomes are going to be realized, but there's so much going on, Vladimir, in these new systems. It's a systems architecture rethink. And if you look at the data center of the enterprise, they all went to the cloud, then they come on, rebuild their on-prem, but then you got the data centers that everyone's watching in the news, $100 billion, $50 billion in North Carolina, another state gets something, billions of dollars. There's a massive build out of infrastructure for these systems. An old data center had servers on a rack. Now they're servers, they're one big computer. The data center is the computer. So this is the mega trend. Okay, you guys are at the center of it. And so I had asked, is it a switch? You said, no, a fabric. Explain the convergence that you guys are on, because it is a convergence of scale out and scale up efficiency.
Absolutely. And, you could view it in a way that the last 10 years of AI were about models and compute engines. And the next 10 years will be about how do you interconnect all these most efficiently to be able to follow the trend of increased expectations from AI. Larger models, smarter, faster, but also, on the other hand, more efficient in terms of performance per total cost of ownership. AI finally has to bring return on investment. So building systems that can be more higher performant, but also bring you that performance per TCO up is really what it's all about. And it's all about interconnect in that space.
Yeah, I mean, because everyone sees the supercomputer chips, the Blackwells, whatever XPUs. You had mentioned that you guys are categorically calling this optical I/O, okay, for scale up. Talk about what's going on there, because scale up is a hot area because, scale out, certainly we cover that too, but there's a little bit of scale out too, because you want to have multiple nodes, but also you want the density and the energy piece. That's where the scale out has got the most demand. Talk about the dynamics between why scale up's important, but also supporting scale out as well.
Yeah, exactly. Scale up really allows, it says so much bandwidth that allows the GPUs to look at each other's memory and really work together as one on a big problem, right? And you've seen this trend already. We started with one GPU on a card, then 8 GPUs on a shelf, then 32, then 64 GPUs working together on a problem. And anytime you made that upgrade, you actually were able to not only crunch a bigger problem, but also crunch it with better return on investment. And this trend just continues. 256, 5, 12,000, 10,000 GPUs. That's kind of the scope that we can cover with optical I/O. Fortunately, electrical I/O, or fortunately for Ayar Labs, electrical I/O cannot follow that trend. It basically is limited to a meter of reach, and you simply cannot connect that many GPUs within a meter without blowing up the power density and kind of cooling limitations in the data center. And this allows us to create a cluster-wide AI inference that boosts the key performance metrics, both smarter AI, interactivity, but also performance per TCO, which is really the key finally to getting a return on investment in AI.
Yeah, and you made a good point. You want the throughput, which you can deliver. And if you don't have optical, you're going to have electrical. That's heat, too. So in these dense scale-up systems, talk about that dynamic. I know it's kind of like a little bit off the topic. Well, it's not outside, it's on topic, but it's like not obvious to many. The heat that's generated and the density of the scale-up is a huge design factor.
Absolutely. And look, just looking over the last few years, we've gone from 30 kilowatt racks to 80 kilowatt racks to 120 to now 180 kilowatt racks. Talk about 600 kilowatt racks in a couple of years. That trend is clearly unsustainable. It's essentially an exponential trend. And once you switch over to in-package optics, allowing you to go anywhere with low latency and high bandwidth and not as much energy expenditure, you are able to kind of flatten that. You can use 100 kilowatt racks, but 100 of them to give you that level of compute power that you need for the future AI workload.
Talk about some of the efficiency. I mean, latency is one thing, heat's another. Talk about network hops. That's another factor. Where does that come into play?
Absolutely, you're right on the spot there. With optical I/O, we allow both compute sockets and switches to have a much higher radix of connectivity. And that allows you to connect to more peers as well as have a flatter switch network. So minimize this number of hops. Because really the key in these scale-up fabrics is the latency going through the switches. And actually it's the queuing latency. With a lot of bandwidth and a lot of radix, you also allow path diversity through a bunch of parallel switches, and that significantly cuts down this end-to-end latency. And that's one of the strong points of optical I/O as well.
Yeah, it's a very nuanced point, but a lot of people don't understand that those hops can also affect GPU cycles as well.
Absolutely. Yeah, GPU basically idles while that transaction is happening. And think of it as you have an extremely expensive compute resource, essentially idling, waiting for the network to return the information. That's basically a very low return on investment on that expensive hardware.
So Vladimir, I got to say, I love your background on your Zoom here on the remote. I can't stop staring at that product. Good branding, by the way, Ayar Labs. But if you look back at the product, it's very intriguing. And I had mentioned switch out of the gate. Oh, it just kind of like came out. But you said, no, it's a fabric. Talk about the product, because I think this is super important as people start to look at these new architectures. The engineering involved in a fabric, it has a switch. So it's in there. So like, talk about, unpack the product real quick. I want to understand, because there's a lot going on in that small package.
Yeah, definitely. And look, in terms of product, it's super important that the product is in the right form factor for two reasons. That the form factor is actually compatible with the high volume manufacturing capability of the right ecosystem, and then that that form factor is also performant, right? So we design and build chiplets. These are optical engines that are co-packaged with AI infrastructure. You can co-package them with the AI accelerator socket. You can co-package them with the switch. You can co-package these chiplets with the memory boards. And once you decorate these packages with these optical engines, you enable more than an order of magnitude higher bandwidth and radix out of these sockets, right? So that's the key. The way of building these chiplets needs to be essentially extremely compatible with the high volume manufacturing ecosystem. And so earlier we mentioned our partnerships with in the TSMC ecosystem, as well as most recently announced All-Chip partnership, where we're partnering with All-Chip to actually bring these optical chiplets, optical I/O chiplets into the package that they're assembling for hyperscale data customers.
You beat me to the punch on the ecosystem. Talk about the All-Chip and the TSMC relationship. What's going on there? What should people know about?
Look, this is the ecosystem in the world that cranks out the AI accelerators and optical engines for the AI infrastructure. The CUBE process that we are using at TSMC really allows you to build breakthrough performance optical engines. In terms of density, we're looking at essentially a decade of scaling ahead of us, both in energy and throughput efficiency of these optical engines. But also more importantly, with partners like All-Chip, we're getting these optical engines into very complex AI socket packages. You have a CoWoS interposer there with a lot of memory and compute. Next to that, on a substrate, you have optical engines with detachable connectors. Someone has to put all of these things together. So we're working very closely with them to enable this type of ecosystem.
And that announcement was what, a reference design or reference implementation with All-Chip? Because they're custom ASIC. That's like, I mean, TSMC, everyone gets that. They're like they're the king of the castle right now. Everyone loves them. You got to stand in line, and you know, we know what they've done. All-Chip is doing what? Are they putting a reference architecture together? What specifically do they have going on with you?
Yeah, think of it as someone needs to create an enablement, right? In the end of the day, All-Chip does both kind of the front end and back end ASIC services. They work on one end with their hyperscale customers to build the ASICs or accelerators, but they also do back end integration. How do you put these chips all together on an interposer? How do you get that interposer into a package? How do you get optical engine into the package? How do you test all that, right? So they enable a lot of that backend so that it's essentially a turnkey solution for a hyperscale customer.
Yeah, and that's going to increase the volumes and quality. Doug, what's it take to do high volume manufacturing for co-packaged optics?
Sorry, can you repeat that?
What will it take to get the high volume up for manufacturing?
Yeah, look, we're going through that every day right now in Ayar Labs. And a lot of it is about the back-end manufacturing. This is what's so great about TSMC ecosystem, that you have a lot of partners you can access to enable volume testers for TSMC CUBE process specifically. Some new kind of test capabilities are needed. And we're working very closely with top-tier tester manufacturers to enable these things. And the hardware we have right now is going through these pipelines, cleaning up those assembly steps. So you have that ecosystem you can rely on and put together to really get the high volume product. But it's that back end that's very critical. We've kind of solved the front end. The design works, the platform works. What you really need is this high volume manufacturing back end that a tier one customer can access and essentially use to scale to extremely high volumes that we see in these AI applications.
Okay, so you got the front end done, you got the back end. As co-founder, you got to be pretty pumped up right now, all that work. Take us through, how long were you guys working on this? What was the origination date? What was some of the stories? Now you're on the cusp of marketing it, getting volume going. Obviously, again, the market's perfect for you guys. Again, I think it's the convergence of scale up, scale out. It's this phenomenon. Scale up needs the most help right now. But clearly, the data centers are getting bigger. They're wanting to be big, medium, and small AI factories are coming to the scene. How do you feel? What's it like? Tell a story.
It's actually a great feeling being able to long ago kind of read the tea leaves, essentially, and actually in few stages. As it's easy to retrospect back kind of how things worked out, but usually there's a series of step recognitions that you need to make to arrive at a certain spot. And look, the first one we made, starting back to our academic days at MIT and Berkeley, and CU Boulder kind of partnership of the three schools to have a big DARPA project looking at essentially solving the interconnect problem for high performance computing. Back in the day, let's say 10 or more years ago, AI was very nascent. But we did recognize that memory systems, essentially memory bandwidth problem for high performance compute. And we tailored the whole approach to essentially taking the photonics technology from the lab immediately into the fab. We had partnership with Global Foundries, where we, and actually IBM before that, to actually demonstrate that, but really focusing on this high volume manufacturing aspect. And then the second realization was roughly around when transformers were born as a concept, that this is going to grow immensely in terms of as any no workload previously that was ran in the high performance computing. And the third realization roughly around, let's say 2017, 2018, once we already started the company, was that the chiplet is actually the form factor that is going to be the best insertion for several generations into this type of computing, because the Moore's law was kind of dying out, and you had to heterogeneously create an environment anyway inside a compute package. And that was the perfect entry for optics, so that it's actually scalable and also high volume manufacturable.
Yeah, and the heat side of it, the energy savings cannot be dismissed. It's so important. You guys got that down too. I love the optical market right now. It's funny, Vladimir, supercomputing is a conference that's so hot right now. It started in 1988 when I graduated college, and it was kind of like in the HPC area, high performance computing, where you've been doing your research. It's like it moves along inch by inch, and now it's actually a supercomputing show. We're talking about supercomputing, like real large scale systems. It feels like we finally made it.
Yeah, and a great driver set of applications that are really challenging both software and hardware. Look, the way we see it is that, for AI applications, you have these two metrics that matter. It's how fast it responds to a single user and how smart it is. Or a user could be another agent, AI agent, or a human, right? So you have that interactivity axis, but you also have this performance per TCO axis. And interestingly, for any hardware generation, you have this Pareto curve that you can ride with software. But the only way to move upwards on both of these is to create a new hardware architecture that is optimized for that workload. And that's kind of what we're doing here with Photonic Fabric and our optical I/O powering that connectivity.
And it's so consistent with the market. That's the Pareto curve. Jensen's famous charts. He loves to talk about that all day long. This is why we love this market. Final question, what's the status? When are we going to see the product come off the line? When are you going to put it in the hands of builders? When's that all going to go down?
Yeah, look, it's a super exciting time for us at Ayar Labs. We're deep in the trenches, really going through the execution phase, getting the hardware through the fab, setting up the testing backend, infrastructure, and the high volume aspects of it are critical. It's not like a lab infrastructure you're putting together. It really is an ecosystem set of partnerships that are driving these equipment enablements. And look, we are working as fast as we can. The demand is there. We're talking maybe 18 to 24 months is kind of our window, and we're trying really hard to make it.
I have one final question that's just popped in my head since I got you, because you're an expert. I was talking with Sid, one of our analysts, former Gartner, 10 years, been in Bell Labs. We were talking about that same paradigm shift, that big shift, and the vendors become the new vendors. And for the folks like the Dells and the server vendors, and you got NVIDIA plowing the fields and innovating, you got the optical engine, fabric, and device. These new systems are here, and it's the new curve. It's the new way. It's clear to people. How do those existing server vendors and other suppliers, in your opinion, how should they be thinking about it? Because, they're just more servers. They're connected together. So the AI factory to me is just a bunch of servers that no one sees, or it's somewhere and connected. It's not like a server load Linux on it and wrote an application. It's a whole nother ballgame. What's your view on that? What's your opinion on I mean, the game is still the same. It's just the landscape changed.
Look, in one hand, you kind of transfer one set of challenges to another set of, let's say, more manageable challenges, but you still need to solve them. It's an absolutely crucial question and something that we're engaged in very closely with our partners across the whole stack. Think of it as you said, the whole rack or a cluster. We build an optical engine, laser source. How does that get integrated into the package, into the board, into the rack? There are innovations at every level of the stack, and we're working closely with our partners to highlight where the opportunity for a new thing is, and actually how to create these systems most efficiently, cost effectively.
Yeah. And their systems, and it's a systems revolution again. It's back. It never left. It's system. And the young developers have that systems mindset too. They're starting to see the engineers start thinking about consequences, second order effects. Vladimir, thank you so much for being part of our community and part of our program. And congratulations to you and the team for what you do. And we'll keep in touch. A lot to follow up on for sure. And again, it's just beginning for you guys and the whole industry. Thanks for coming on our AI Factory inaugural kickoff.
Absolutely. Thank you, John.
I appreciate your time. I'm John Furrier with theCUBE. We are here at the CUBE's NYSE studio. Of course, we have our Palo Alto studio connecting Silicon Valley and Wall Street. Again, the AI Factories is a concept to simplify all the complex systems that are being engineered and connected to provide great data movement, high intelligence, and actually powering the AI native applications. Again, we will continue to cover this. We're doing our part to bring you the data to you. Thanks for watching.